So we're going to start off by looking at some function notation and looking at what actually is a function. Now, in terms of a function, all a function does is applies some rules to an input, so something you put in, to get your output, so the item that you get out. Now, in this case, our function taking us from x to 2x could be something like times 2. Or in this case, it could be times 4 take away 2x. Like, there could be multiple different ways of doing it. This would be its simplest form, but the function at its simplest form just means you apply something to an input and then you get an output. Graphically, that would typically be you put in x, you apply some function which you might write as f of x, and then out of it you would get your y value. Okay, so in terms of function notations, this just means a function of x, and you might see it sometimes written as g of x or h of x, and all these are just different functions. So starting from f and then unimaginatively, I suppose, going to g and then to h. So just to recap, a function then is just something you're applying to an input to get your output. So if I have a look at a specific example, so here we've got f of x equals x squared plus 2. Now in terms of this function, what does it do? Well, if you put in a value of x, you square it, and then you add 2. So in other words, you square your input, so square the input, then add 2. Okay, so that's what this function actually does. So if we were to do it as a diagram, so it's called I and my input. So if my input was x, you're then applying your function, so f of x, and your output then would be x squared plus 2. So you put something in, this is what you get out. We're going to use that idea here then for f of 3. So when it says what is f of 3, f of 3 just means you're putting 3 into your function. So wherever you see x, you're replacing it with 3. So x squared will become 3 squared plus 2. So f of 3 in this case then would be 9 plus 2, which is 11. F of minus 5, same idea. We're replacing x with minus 5. So I've got minus 5 squared plus 2. So you notice how I put minus 5 in brackets, because we're squaring all of it. If you're doing negative numbers on a calculator, then you should always put it in brackets as well. So minus 5 squared is 25, plus 2 then would be 27. So this is all about applying an input to your function, so substituting this number in for x. The example here underneath is looking at if f of a is 38, what is a? So it's like saying, I know that my function of a is equal to 38, so what did I start with? So if I put a in place of x squared, that means I'd get a squared plus 2, and I know that that's going to be equal to 38. So f of a then would be this function here just with a in it. Now a squared then would be 36, so subtract 2 from both sides, and then a is the square root of 36, so it's positive or negative 6. So 2 possible solutions. Okay, so that's where we are in terms of function notation. Now, moving on to inverse functions, what an inverse function does is it takes you from your output back to your input. So if I draw a small diagram to illustrate that, if I've got my inputs here and then some function takes me to my output, an inverse function takes you back again. So to go this way, we would need an inverse function which we call f minus 1 of x. Okay, so that is the inverse function. Now, the way that we do that is as follows. So I've got 4 simpler examples and then 2 that are slightly more complex on the right. So if I look at the first one, so I'll number this one 1. So if I look at the first one, I've got f of x equals 5x. Now, what I'm going to be doing is writing that down as y is equal to 5x. So treating it like I would on a graph. So saying that my output can be y, and what my function is 5x. Now, we know that in a graph, what we input is x, and then what we get out is y. So if I'm looking for a function of x that would be the inverse, that means my x and y values are going to be the other way around. So what I'm going to do then is swap my variables around. So I'm going to write it as x is equal to 5y. So just replacing these. Now, to make this inverse function something that we can make use of, I need to make this into the form y equals something. So to make this y equals something, I need to rearrange it. So to get y by itself, I divide by 5, which will give me y is equal to x divided by 5, which means that my inverse function will be x divided by 5. Now, when we think about it in the context of this diagram up here, if our function was 5x, that means we're multiplying by 5. Now, the inverse then would be to divide by 5, which is what we have here. So conceptually, so if you think about it a bit more literally, I suppose, it makes sense. So this is times 5, this is divide by 5, and that's where the idea comes from. Now, if we apply the same things to 2, 3, and 4, so I'll do 2 up here. So I've got y is equal to 1 plus x. If I change my variables around, I've got x is equal to 1 plus y, which means that y is equal to x minus 1. So in this case, f inverse of x is x minus 1. And again, if we look at it here, to x we've added 1. So to go back again, we would take away 1. So it's like the opposite. For question number 3, we've got 6x minus 4. So y is equal to 6x minus 4. If I swap, I get x is 6y minus 4. Now if I add 4 to both sides, I get x plus 4 is equal to 6y. And then if I divide by 6, I get y is equal to x plus 4 divided by 6. Which means that, if I scroll down a little bit, that f inverse for this one is x plus 4 divided by 6. Now looking at the fourth one, I've got x plus 7 divided by 3. So I'm just going to maybe do that here on the side. So y is equal to x plus 7 divided by 3. So again, I'm going to swap. So I've got x is equal to y plus 7 divided by 3. Now, because it's all been divided by 3, that's the first thing I'm going to counter. So if I multiply both sides by 3, I get 3x is equal to y plus 7. And then if I subtract 7, I get y is equal to 3x minus 7. So in other words, f inverse of x is 3x minus 7. So far, I've swapped the variables around and then rearranged it to make it y equals. Now looking at the two more difficult ones, these both have x's in more than one place. So for this one here, I still apply the same idea. So y is equal to x divided by x plus 3. I swap my variables. X is equal to y divided by y plus 3. But now I need to rearrange it to make it y equals. So if I multiply, I get x times y plus 3 is equal to y. And then I can expand that to get xy plus 3x is equal to y. And now what I want is y equals, and I've got y appearing in more than one place. So what I'm going to do is subtract this xy. So I've got 3x is equal to y minus xy. And the reason why I've done that is to keep this positive. Now, I've got y in both terms. So if I factorize, I would get y1 minus x. So y is common to both, and then what's left would be 1 minus x. So y times 1 is y, and y times x is xy. And now I can divide. So y would be equal to 3x divided by 1 minus x. Therefore, f inverse of x is 3x divided by 1 minus x. Now, looking at the one on underneath, it's very much a similar idea. So again, I'm going to use y equals 2x minus 1 over x minus 1. So x is 2y minus 1 over y minus 1. I'm going to multiply. So xy minus x, I've just expanded the bracket straight away, equals 2y minus 1. And now, again, what I want here is to have something that's mainly positive. So I'm going to add x to this side, and I'm going to subtract 2y from this side. So I'm going to have xy minus 2y is equal to x minus 1. And then factorize the left-hand side, so I get y x minus 2 is equal to x minus 1, and then divide. So y is equal to x minus 1 divided by x minus 2. So in other words, f inverse of x is x minus 1 over x minus 2. Just to perhaps clarify this step here, so I did xy minus x minus 2y equals minus 1, and then by adding x you get xy minus 2y equals minus 1 plus x, which I've just written in the order x minus 1, so just to be clear on that. Next we're going to have a look at is composite functions. So if I have these two functions here, so f of x and g of x, we can write composite functions in a number of ways. You might see it as f of g of x, or f of g of x, or f of g of x. And sometimes this isn't coloured in, but they all mean the same thing, and it just means composite functions mean to combine the two functions together. So for this one, I'm going to start with some numerical examples and then have a look at an algebraic one. So if we were looking at, for example, f, g, 4 perhaps, then all this means is that we're going to be putting g of 4 into f. So we read it from right to left. So we're going to apply f once we've done g of 4. So to find this one, we could find g of 4, which would be 4 squared, which is 16, and then we would do f of that. So f of 16 then would be 3 times 16 plus 1, which is 49. Another way you could look at it is if you did f of g of 4. So in that case, that would be f of 16, so you come up with the same sort of idea. Just to illustrate that it wouldn't necessarily be the same the other way around, if we had g of f of 4, then we would do f of 4, which is 3 times 4 plus 1, so 13, and then g of 13 would be 13 squared, which is 169. So the order that you do this is important, okay? So we always read from right to left. Now if we were going to do this algebraically, what we would do is the following. So if we were going to do f of g of x, then what we would do is substitute g of x into f of x. So we would do f of g of x, so f of x squared. Now to do f of x squared, everywhere you see x, you replace it with x squared, because we know that f of x is 3x plus 1. So f of x squared then would be 3, and then x would be x squared plus 1. So you place g of x, so in this case which was x squared, into f. So where you see x, you replace it with x squared. Just to show you that the other way around, if we were to do g of f of x, that means we would be doing g of 3x plus 1, which in this case then would be 3x plus 1 all squared, because g of x is x squared, so if you're putting in 3x plus 1, then you're doing 3x plus 1 squared. You could leave it like that. If you needed to simplify it, you could expand the brackets, so it's 3x plus 1, 3x plus 1, and then if you were to expand it, you would get 9x squared plus 6x plus 1. Okay, so that's how you would do it algebraically. Now looking at some exam question examples. So the first one here, we've got f and g are such that f of x is 3 bracket x minus 4 and g of x is x over 5 plus 1. First question says find the value of f of 10. Now f of 10 would be 3 lots of 10 minus 4. So we're replacing x with 10. So in this case that would be 3 lots of 10 minus 4, which is 6, which is 18. So that's just the same as the notation we were looking at the start. For g inverse of x, so again, so we know that y is equal to x over 5 plus 1, and then interchanging, we get x is y over 5 plus 1. Now in this case, the first thing we're going to do is take away the 1 because not everything is being divided by 5. Therefore, x minus 1 is equal to y divided by 5. And then if I times it by 5, y would be equal to 5 lots of x minus 1. So therefore, g inverse of x is 5 lots of x minus 1. Now you can expand it if you wish, but you can also leave it like that. Part C says show that f of x is 9x minus 48. So that means into f we're putting 3 lots of x minus 4, which I'm going to expand to be 3x minus 12. Now that means every time I see x I need to put this in. So 3x minus 12 into f is what we're going to be doing. So that gives us 3 of, now x is 3x minus 12 minus 4. So just bearing in mind here that this here in the original function was x. So if we simplify this and then expand it, this gives us 3 lots of 3x minus 16, which if you expand gives us 9x minus 48. Remember, if it says show, this is what you want to end up with. This is what we ended up with, so we must have done it right. Looking at another one, so we've got 2 functions here, and it says find g of f of 4 given your answer as a fraction. So what I'm going to do is find f of 4 first. So f of 4 is 3 times 4 squared, which is 3 times 16, which is 48. So then g of 48 is 1 over 48 minus 2, so it's 1 over 46. Leaving my answer as a fraction. So looking at the next one, so we've got an inverse function to find. So it says the function f is such that f of x is 4x minus 1. Find f inverse of x. So again, y is equal to 4x minus 1, which means that x is 4y minus 1. Now if I add 1 to both sides, I get x plus 1 is 4y. And then if I divide by 4, I get y is x plus 1 divided by 4. So therefore f inverse of x is x plus 1 divided by 4. For part B, it says the function g is such that g of x is kx squared, where k is a constant. It says given that f of g of 2 is equal to 12, work out the value of k. So the first thing I'm going to do is find out what f of g of 2 is using these equations. So first and foremost, if we find g of 2, then g of 2 would be k times 2 squared. And 2 squared is 4, so g of 2 then would be 4k. And then we can put 4k then into f. So f of 4k then would be 4 lots of, so replacing x with 4k, so 4 lots of 4k minus 1, which is 16k minus 1. Now we know that this is equal to 12, so we can now set up an equation. So 16k minus 1 is equal to 12, so 16k is equal to 13, so k then would be 13 over 16. So our penultimate question then, so we've got f of x is x cubed and g of x is 4x minus 1. Find f of g of 2. As you can see, f of g of 2 seems to be quite a popular combination. So g of 2 is 4 times 2 minus 1, which is 8 minus 1, which is 7. And then putting that into f, so f of 7 then would be 7 cubed, and if we type that into our calculator, we'll get 343. That's if you don't know it off by heart. For the bottom, it says h of x is f of g of x. Find an expression for h inverse of x. So we're going to have to start by finding h of x. So we're going to do f of g of x. So f of g of x then, so f of g of x means we need to do f of 4x minus 1, which would be 4x minus 1 all cubed. So therefore h of x is 4x minus 1 cubed. And I'm not going to expand it, because if we expand it, it will be nigh on impossible to find the inverse of. Now to find the inverse, we're going to do what we've done every time so far. So do y is equal to 4x minus 1 cubed. Switch them around, so x is 4y minus 1 cubed. Now the first thing I'm going to do is remove the cube by cube rooting. So the cube root of x is 4y minus 1. And then if we add 1 to both sides, I get the cube root of x plus 1 is 4y. So moving up here, that means that y then is equal to the cube root of x, so it's there, plus 1 all divided by 4. Therefore, h inverse of x is the cube root of x plus 1 divided by 4. So our final question, so we've got 3 parts to it. We've got to find g of minus 4. So g of minus 4 then will be minus 4 squared plus 2, which is minus 4 squared is 16, so 16 plus 2, which is 18. For part B, it says show that g of f of x is equal to this. So into g, we're going to be putting in 2x minus 3. So we're going to be doing 2x minus 3 squared plus 2. And then to show that that's that, we're going to need to expand this. So at the side here, I'm going to do 2x minus 3 times 2x minus 3. So that gives me 4x squared minus 6x minus 6x plus 9. So then this is equal to 4x squared minus 12x plus 9 plus 2, which is 4x squared minus 12x plus 11. So the same as what we were asked to show. For part C, it says solve f of g of x equals g of f of x. Now we know what g of f of x is from part B, so we need to work out what f of g of x is. So f of g of x would be f of x squared plus 2. So that gives me 2 lots of x squared plus 2 minus 3, which is 2x squared plus 4 minus 3. So plus 4 minus 3 is 2x squared plus 1. And now, if they're equal to one another, so I'll scroll down, then that means that 4x squared minus 12x plus 11 is equal to 2x squared plus 1. Now, if I equate this to 0, so subtract 2x squared from both sides, I'll get 2x squared minus 12x plus 11 is 1, and then subtract the 1 gives me 2x squared minus 12x plus 10 is equal to 0. And now as they're all even, I'm going to divide by 2, which gives me x squared minus 6x plus 5 is 0. And now I can solve this by factorizing. So two numbers that multiply to give 5 and add to give minus 6. Now the only factors of 5 are 1 and 5. To add to give minus 6, they must both be negative. So x minus 1 and x minus 5. That means f of g of x equals g of f of x when x is 1 or x is 5. So those are our two possible solutions from here. So either x minus 1 is 0, so x is 1, or x minus 5 is 0, so x is 5.